All right, good morning, everybody. For those of you who are not in class on Friday, just a couple of administrative things to pass along. Okay, we're having a quiz on Monday, and if you keep up with things and watch this video and do the homework, I think you should be in good shape to take it. You know, you can plead your case and put it off, but you know, we got to get it done pretty quick. So anyway, watch the videos that I post. I may put up another one and keep up to date. Now, when you take this quiz, you will have a choice of calculators. You can use the little small scientifics. Those we've been working with, so hopefully you're real familiar with those. You can use Nspires too. When you use the Nspires, or if you choose that option, you would really best know things like how to be in degree mode and how to do float 6 and that kind of thing, how to do store, because I am not going to be training folks on what to do on the calculator in the middle of some kind of assessment. This is, you know, that's kind of the way it is. You can always ask for the other calculator in case of emergency. So there's that. We also have a unit circle super quiz on Wednesday. This is announced. It's like doing 3 unit circle drills at the same time. So it's going to be 30 questions, 2.5 minutes per group of 10, so that's 7.5 minutes total. It does count as a full quiz grade because, you know, the 3 varieties that are only 10 problems each count a third. So don't panic about it. It's going to be at the level that you're used to doing. I mean, what more can we do with the unit circle that we haven't done yet? So, you know, just be ready for it. And don't forget, if you do unit circle drills and you get done 20 seconds early, then for groups of 3, that means you'll be done a minute early, which you can then use to go back and check things. We do have a test on Friday, so we're going to soon wrap up law of sines and law of cosines. Okay, so on to what you missed on Friday. All right, the notes that you're seeing here on the screen are actually not in your packet. They are available for download and printing. Just go to your law of sines and cosines link, open it up, go into reprints, and you'll see it. You can print it off. There are problems on the back, 7 problems. That would be the assignment. So you do not have this in your possession. I passed it out on Friday, but just download it, print it off. Okay. So we did do law of cosines on Thursday in order to do the ambiguous case where you have 2 triangles present. And that's fine. You know, you've got to use the quadratic formula, and it does seem a little kind of intense, maybe a little intimidating, but it's really not that bad given the fact that things like 10 cosine 40 degrees is just a number. So, but anyway, this is another option, and this is probably a more popular one because most people want to do these side-side angle type problems with 2 triangles just using law of sines, and it's very doable, very possible. All right, so here's your picture that you're supposed to look at, and you can see from the 2 red sides, this would be your swinging side, that you've got 2 triangles. One this way, one this way. And when you set up your questions, you're just going to get things like what you see here. All right, so you're given an angle and 2 sides. Well, I would set up your angle always in the lower left, just like this. And you will have a side opposite it that will be here. So make that this side. So if this is angle C, this will be side C. Then they're going to give you another side, and just go ahead and put that in between the angle and that other side. So put it right here, okay? And it's not like that's the only arrangement that you can do, but basically kids like it. And if I start putting, you know, the swinging side off of here and put it here instead, kids just start to freak out. All right, so set it up like this. And this is going to be very possible to do checking to see if it's got two triangles, if it forms two triangles. Because you remember how to do it. We pretty much just go ahead and drop down an altitude, and calculate h, compare it to a, and if a is greater than h but less than this side here, side b, well, then you've got two triangles. I'm actually going to go ahead and show you another option for determining if you have two triangles. I know that we're starting to inundate you with options. It is not meant to overwhelm you. It is basically just meant to give you things that you can try, and whatever ones that you prefer, that's what you need to stick with, because we're not going to say, all right, do this triangle with law of cosines, this triangle with law of sines. It's going to be your choice. One thing to remember is that once you get your two angle B's, this one and this one, all right, the sum of those two angles will be 180 degrees. And that's a good thing to remember, because, it's just something that'll help you. Also, this angle here has to be acute, right? Because if I move side A so that it's straight up and down, that's 90. And if I further rotate it to the left, then this goes obtuse. So this will be acute, always, okay? In the two triangle situation. So get rid of that. And okay, so here are your options. Now the option after the word or, this one here, is the one you're used to doing. That's dropping down the altitude, calculating h, and then just going from there. But this three-step process is one thing that you can opt for. So here's what I'm going to do. I'm going to try to draw a triangle, see if it'll draw straight, or at least in a usable way. All right, that'll be usable. All right, so this is how I would set up any triangle. They're giving me an angle. This is going to be 33 here, and I'm going to call this C. They're going to give me a side C, so C equals, 6 inches? And then they're going to give me another side, which I'm just going to put right here, sort of in between the two. So B will be 10 inches, and that will automatically make that angle B, and since you've got two of the three, this is automatically angle A, and this is side A. Okay, so looking at these instructions, all right, we'll start out with this first one. It says find the value of the unknown angle using law of sines. Well, clearly it's not going to be angle A, because you can't do sine A over A and have no numbers to work with. So you're really going to be looking at B. So we'll just go ahead and just say, all right, sine 33 degrees divided by 6 equals sine B over 10. All right, so then you can go ahead and generate an answer. You're going to have to, 10 times sine 33 divided by 6 will give you a number. That number will be then used for inverse sine, and you're going to get the measure of angle B is going to be 65 point, I believe it's 194. So 65.194 degrees. And remember, I told you that's the same one that's going to give you an angle here and then an angle that's obtuse. And remember, I told you the first one will be acute, and so there it is. All right, so that's the first thing. It says once you find, we're on 2, once you find your angle, and there it is with inverse sine, subtract it from 180 to find the possible second angle. Okay, so 180 degrees minus 65.194 degrees, that'll give you 114.806. All right, that's what would be this angle up here. Okay, so the 65 point, what was it, 194 is this one here, and then the obtuse, the 114.806 degrees is this one. All right, So what does it then say? In other words, we found the supplement. Okay, add the supplement to the measure of the original angle. This is the original angle right here. All right, that's going to be fixed in both triangles. So we're just going to go ahead and add this 114.806 to 33 degrees. So 114.806 plus 33 degrees. That's going to give you 147.806 degrees. All right, so that's what we have for the second thing. We're actually, I guess, now in the third. So they're saying if the sum is less than 180, which, yeah, that is, you have two valid measures and two triangles. If the sum is greater than 180, you only have one. All right, all that they're saying here is that this is your 114.806 degrees. Sorry, that's a little light. Right, and then you have 33 degrees. That means if you add these up and they're less than 180, you have enough left over for this angle right here, and hence a second triangle. Okay, does that sort of register with you? Okay, so let me clean up some of this stuff. There it all goes. Okay, so we have two triangles. According to this process, you have two triangles. Okay, good. So we've got the ambiguous case with two triangles. So let's solve them using law of sines. So here's the first triangle, and over here we'll do the second. So starting with the first, let's write down what we know. The measure of angle C is 33 degrees, right? That's this over here, and we can actually go ahead and put that with the second one too. So the measure of angle C is 33 degrees. We know the measure of angle B because we calculated it right here. So that'll be 65.194 degrees. And the other one is going to be the supplement. So the measure of angle B here is just going to be 114.806 degrees. And that comes from here. So then we can add the two together, 33 plus 65.194, subtract it from 180, and we get the measure of angle C. Whoops, let's take that back a little bit. That would be the measure of angle A. So change that. So add those two together, subtract from 180, you get 81.806. 806 degrees. And we can do the same thing over here. The measure of this angle A, remember that this angle is not fixed, so it'll have two measures. Add 33 to 114.806, subtract, add 33 to 114.806, subtract from 180, and you get 32.194 degrees. All right, so all of the angles are done. Well, not only that, but you know two of the sides. So you know, for example, side B is 10 inches. And you know that that's the same thing here. Those are fixed. They're not going to change. You also know that side C is 6 inches. And that's going to be again for both. So now it's just a matter of using the law of sines to get the third side. So for this one, I'm just going to use what I was given, sine 33 degrees over 6 equals sine. All right, we're looking for side A. So we need the angle A. That's going to be 81.806 over A. Now, it's not a bad idea to have that 81.806 stored to more decimal places. You could also go to 4 or 5 places of accuracy. That will tend to work, all right? So then go ahead and solve for A, and you get A will be 10.904 inches. And that triangle is complete. And then you just do the same thing for the second triangle. So sine 33 degrees divided by 6 equals sine. Now we need a different measure for angle A. That'll be 32.194 degrees. And that'll be over the other A. Okay? Because once you move, you know, this side C over to here, B is side A is just going to shorten from all of this just down to this. All right? So when you get through doing your cross multiplying and everything, you're going to get A for this one will be 5.869 inches. So there you go. That's what you need if you want to just solve the ambiguous case with two triangles using just the law of sines. So good deal. I'm just going to go ahead and try to close this out, and we will see each other on Monday.